Thank you for joining us for today's Masterclass webinar series. Today we'll be covering SQL Server Advanced Data Protection and Service, Part 1. Part 1 of 2. Part 2 will be next week. And in today's session, we're really going to lay down a strong foundation of Actifio and SQL knowledge and how they work together so that when we really dive into some of the more complex concepts next week, everybody's well equipped to really enjoy that webinar. Before we get started today, our next webinar, as I mentioned, will be SQL Advanced and Complex Configuration with Best Practices. And that will be on Tuesday, July 17th at 10 a.m. Eastern Time. And we also have our upcoming live remote Sky Administration class, and that is from July 23rd until the 27th. And thank you for joining us. Today's webinar is SQL Advanced Data Protection and Service. I'm your host today. My name is David Fowler. I'm the manager of the Global Enablement team here at Actifio. And joining me today is Mike Salins. He's one of our principal product managers. And with that, I'll hand it over to Mike. Mike?
Thank you, David. Good morning or good evening or good afternoon, everyone, depending on where you're located. Thanks for joining today. Definitely appreciate it. As David said, this is going to be a two-part session. The first part being conceptually to lay down some foundation work and to cover the most common tasks and configurations that are out there. What I'm going to be doing here is going to be a mixture of presenting information that you have probably never seen before and heard before, mixed in with information that you have seen, but my goal is to go a level deeper on the content as we explain it. So as I start going, if you've seen one or two of the slides that I'm using, rest assured that if you're listening, you'll pick up some additional information that you probably have not heard before, or you may have me explain something in a way different from what you've heard before. And then, of course, there's definitely some new content. So high-level agenda, what we're going to cover, I'm going to start out with the foundation work. So I'm going to talk about how Actifio captures Microsoft SQL Server data in different configurations. I'm going to touch just very lightly on things like availability groups, for example, but I'm not going to go very deep into that. That's going to be on the next session next week where we go deep. I will definitely talk about the difference in mechanics and storage layouts between database backups versus transaction log backups. I'm going to talk a bit about VSS. This seems to be an area of particular interest for a lot of companies that I speak with, asking questions based on past experiences. A lot of people are asking, is this really safe to do? Is this going to impact my production environment? So I'll talk about how we use it, why we use it, what it does, and where some of the problem areas historically have been. Then I'm going to talk about management best practices. This is going to be a discussion about when you're setting up backups and data capture, what level of granularity are you doing it at? Are you capturing the entire instance? Are you using consistency groups? Are you backing up individual databases? I'll talk about the differences between them and why you'd want to use one versus another, and what some of the best practices are there. And then finally, I'm going to touch on data access, and I want to make sure that we are really, really clear, because this is another area where I tend to see a lot of confusion and get a lot of questions. With this presentation, this webinar being targeted towards existing customers and hands-on, I do expect and encourage questions. So as David said, use the questions panel in the GoToWebinar to submit those questions. If there's something straightforward that David can answer, he may just do that directly back to you. Otherwise, he will interject periodically throughout the webinar in order to share those questions with me and allow me to answer them in the right point in time in the context that's relevant. So let's start out with the basic mechanics of SQL Server. And specifically how Actifio captures data for SQL Server. So when Actifio captures data, there's a couple of things that we do that is very different than other solutions that are on the marketplace. And probably one of the most notable things that we do is that we store the data in this usable format. Now, this isn't anything that you haven't heard before. This is old news, so to speak. But one of the side effects of that approach that we have is that we also get to use storage protocols for our data movement instead of traditional API protocols. And the combination of those two is what sets us apart. So if we take a look at the workflow when we're going to be capturing Actifio SQL Server databases, Microsoft SQL Server databases, it all starts out with the Actifio connector. Right? The connector is a lightweight agent. It gets installed on the server. It inventories what's on that server and reports back to the Actifio Sky or CDS appliance the list of all the file systems, all the SQL instances, availability groups, whether or not it's clustered, and of course all of the databases, as well as their file structures and layouts. Where are all the related database files, what volumes, mount points, etc. Once that information is at the appliance, the customer, you have the ability to apply an SLA, basically, that says how often you want to capture the data, how often you want to run backups, and how long should they be kept, should they be replicated, etc. When we run the first job, what the system does, and this is one of the key concepts to really understand, is the system takes the disk space that's been allocated to the Actifio appliance and put into the snapshot pool, the snap pool, and it actually within this pool creates disks. Those disks, call them LUNs, they're virtual disks. It creates a number of them based on the disk layout of your source production database. So a simple example is if you have a database that has an MDF file on one disk and an LDF file on a different disk and maybe an NDF file on a third disk, what Actifio is going to do is it's going to carve out in this snapshot pool 3 disks, and it's going to mount all 3 of those disks over to the database server. Now, when I say mount, I actually mean it's presenting via storage protocols to that server. It's presenting via iSCSI or it's presenting via Fiber Channel if it's an Actifio CDS. So that the disks on this server, on your production database server, if you were to go into Disk Manager, you would actually see those disks appear there. Now, once those disks are there, this opens the door for us to start putting data onto them, of course. So the way we capture that data and the way we do it with consistency is we start out by taking a VSS snapshot where the included databases in this backup job, which might be just one, or it might be every database in the instance, or somewhere in between the two, they all get snapshotted with consistency leveraging VSS. I'm going to dive a little bit deeper into that after the mechanics discussion and data flow, because I know there's often questions around that. So if you do have VSS related questions, don't ask them just yet. So once we take this VSS snapshot, what we do, the first job, is we simply copy the files related to the databases that we're backing up, and we copy them onto our disks. This is something that could easily be achieved using Windows Explorer or a command line running an xcopy type command. Now, it's our connector that runs the copy, and of course it's a little bit more efficient than your Windows drag and drop. It's got multiple threads per disk, and it's a little bit tunable on performance and whatnot, but it's basically just copying the files. And so at the end of this job, what you're left with on the disks that were mounted are copies of the MDF, the NDF, the LDF files, maybe file stream files, anything that's related to the database gets copied over. So very different than your traditional full backup where it's generating a back file and it's combining data from all the data files into one or more back files depending on the configuration. And we all know, of course, what back files, the backup files that natively get generated out of SQL Server are good for, right? They're good for nothing except restores. You can't use them for anything else. But a copy of the NDF, LDF files, those are good for, well, anything that you'd like to use them for. And we're going to talk in a little bit more detail on when you use them, what are your options and why would you choose one versus another and what does that look like. Now, once the data has been copied across, the next thing we do is we actually unmount those disks that were presented over and we delete the VSS snapshot. So now we have a disk in a set of disks in the snapshot pool that contain those databases. At that point, we take a snapshot of that disk. So many of you may have heard the phrase golden copy in the past. We don't emphasize it so much anymore, but it was really used to refer to that initial set of disks that were mapped over to the server that we copied the data onto that have a full copy. Once we've got that full copy, we simply take a snapshot of that disk. And of course, that snapshot takes no space, right? Initially anyway, because a snapshot of a disk that's not changing, well, they both look exactly identical until one of them starts changing. So initially it's just you have a consistent point in time, doesn't take any additional space, but that snapshot, that is considered your backup. Now, at the same time that we took that VSS snap on the first job here, we also create an in-memory bitmap. This bitmap is initiated with all zeros at first, and at the same time as that VSS snap, we register with the Windows operating system to be notified of any changes for all of the database files that are in scope for this particular job. So whether it's just one set of files, an MDF, NDF, LDF for a single database, or whether it's all of them for every database in the instance, we register with the OS to be notified whenever there's a write operation into those database files. Now, registering to be notified is not the same thing as making a copy of those changes, right? This process of tracking the changes does not actually save the changes in any sort of a journal. It doesn't consume any disk space on the production server. It is not CDP. Very important difference between what we do and a CDP style solution. It's simply got a big list of zeros where each zero represents a block in the database file that hasn't changed. And whenever we get notified that a block of data in the database file is changed, we simply flip the 0 to a 1. So the bitmap also does not grow over time, regardless of the rate of data change in the underlying database files. It's a static size, just changing the zeros to ones. And because we have that bitmap, what it allows us to do is on the second job, on the second day, when we go to run this job, we start out the same way as the first time, where we mount the staging disks. Now, the staging disks we mount on the second job are the exact same disks that we mounted on the first job. I'm going to repeat that just because it's a very critical concept to understand what Actifio is doing under the covers here. When we run a backup job, a snapshot job, the disks that we mount to the server are the exact same disks that were mounted on the previous job and the job before that and the job before that. And we actually then, when we take our VSS snap, create another new bitmap. And then when we copy the data, instead of copying the entire MDF, NDF, and LDF files, we simply look to the bitmap, we query to say which blocks have ones, which blocks have changed, and only those blocks get copied onto our disk. And what we're literally doing is copying the changed blocks, overwriting the same corresponding block that was there from the previous job. As that happens, we'll see our snapshots of the first day starts growing, because it needs to in order to maintain the consistent point in time from that first day's job, while the changes are going into this staging disk. When it's all done, we unmount, and then we take another snap. And now we have two distinct point in time snapshots. Each of them look like a complete full copy, but they're from different points in time.
And Mike, I have a quick question from the audience here. When the MDF and LDF files are in different folders, when we present that, do we present it in discrete folders, or will they both be put into the same folder on the staging disk that we present?
That's a great question. We actually mimic the same directory structure that exists on the production disk. So if you're using mount points, and underneath the mount points you have a folder structure that includes maybe the database name, and then within there you have several different files, maybe 3 NDFs per disk. Then on our side, we'll have one staging disk for each of the volumes, and we'll have the folder that has the database name, and then under there we'll have each of the 3 NDFs that were in the same folder. But whatever that disk layout is, we maintain it. The easiest place to see this is when you have your installation of SQL Server and it puts master, model, and MSDB under programmed files. And you have to drill down under programmed files and then MS SQL Server version whatever, and then data, and then you see the files. When you do a mount from Actifio and you mount up a master, model, or MSDB on our mounted disk, you see that same directory structure starting with programmed files and then drilling down. So we definitely maintain the same directory layout that was on the source. Good question.
And you did mention copying the change blocks. Now, if we only have one block to change, we might not fill it, but what is the minimum size of that block?
That's another really interesting question. I actually wasn't going to go there, but I will. So the bitmap is fairly static in how large it is. And what that means is that the size of the blocks that are represented by each one of those zeros or ones in the bitmap is different based on the size of the database files. So a larger database file, maybe a database file that's 500 gig versus a database file that's smaller, maybe 10 gig, the bitmaps might be the same size, but each block referenced by the bitmap will be larger. It references a larger block of data on the larger database and a smaller block of data on the smaller database. So as we deal with larger and larger individual database files, not total databases, but individual database files, our granularity of change gets larger, which means even a small change, a 4K change, could result in us copying 64K of data or 256K of data or a megabyte if it's a really, really large individual file. This is an argument to support more files of a reasonable size rather than fewer files of very large sizes, because you'll be wasting a little bit of extra space on the really large files. But when we see that one in the bitmap, whatever the translation is for that particular file, and each file has a different block size that is represented in the bitmap, but whatever that translation is, we'll copy that entire block, even if only part of it within there has changed. Another good question.
Thank you, Mike.
Sure thing. So at the end of this process, what we've got is we've got a series of snapshots and one full staging disk. So one disk is full, it's a thick disk, and it has it's formatted NTFS and it has the files on it. And then each one of there's several snapshots of the disk that represent different points in time. This is how the snapshots work. One thing that I saw referenced just yesterday or day before was somebody was using the phrase synthesizing a virtual full. And I wanted to say, if any of you have heard that phrase before, try and forget that you ever heard it. But when it comes to under the covers, we actually aren't synthesizing a virtual full. That almost implies that after we take the incremental block movement, we have to do something to create a virtual full, and we don't. Our virtual full is really just a snapshot of a previous actual full, and that gives us tremendous flexibility in how we use them. Because now, when it's time to use this data, we have a set of disks that has usable files on it. And so what we do is we actually say, you pick the point in time database backup that you want to use. We will take all of the disks from that point in time in that snapshot. We will take a snapshot of the snapshot. It's not represented on the diagram here, but each of these snapshots are actually what I would call immutable backups. No matter what you do, there is no command you can issue to Actifio, no operation in the GUI that you can perform, nothing that will result in those snapshots being modified. They are immutable. But here at the same time, at the same breath, same sentence, I'm saying, and we can do mounts read-write. So how does that work? Well, very simple. We take a snapshot of the snapshot. So the snapshot of the snapshot, again, takes no space initially. Those disks get presented out to a recovery machine, back to the original server, to a test server, wherever it is that you'd like to access that data. And at that point, any changes that are made in the mounted database, they get stored in that snap of the snap. And the source snapshot, the backup image that was used to create it, that never gets changed. And by using this approach, we can actually spin up multiple mounts of the same source by just simply taking more snapshots of it. So you might have one backup and do 8 mounts from it to 8 different servers for 8 different QA people. They all think they have their own full copy. It's really only storing the deltas, and what we really have is one full copy, a snapshot of that full copy representing a point in time, and then 8 snapshots of that one snap, each of them presented out to servers that are accessing them and doing things with the data through SQL Server. Now, right about this point in the discussion, I usually get the question, do you support transaction logs and how does that work? So let's take a look at the answer is of course yes, and there's some discussion we'll have around best practices there, but let's just take a look at the mechanics of transaction logs because it's similar in some ways, but it's also different in some ways. So to start out with, what's similar? Simple. We still store data in the usable format. In that, we create a disk and we put data on it and we snapshot it. We get the data onto that disk by mounting the disk to the server and then copying data onto it. That's where the similarities end though. The way that we manage retention is very different, and the contents of those files is a little bit different. And I'll explain what I mean here. So the process for transaction logs always starts out with the Actifio connector, of course, right? You already have it there if you're doing your database backups. When we run our first transaction log job, the system will look at what you've defined in the policy as the retention period for logs. And rather than looking at the production disks, so one thing I didn't really mention very much on the previous slide is when we're creating these disks to present to the server for the first time, how do we know how big to make them? And the answer is we look at the production disks. So if you have an MDF, an NDF, and an LDF file on 3 different volumes, and so we're going to create 3 different disks, we're looking for each one at the corresponding production disk size and making it the same size plus a little bit of buffer space. Now, this is a thin provision disk, which means even though you might have chosen to back up just one database instead of all of them, and therefore maybe you wouldn't need it to be as large as the whole source disk, it does no harm to make it that large because it's not consuming any extra space. Now, on the log side, that method is very different. We have to look at the retention period because instead of having one copy of one backup and then just keeping snapshots of it, that becomes very complicated if you want to use the logs. Now you have to mount back a whole bunch of disks, a whole bunch of snapshots, if you're going to roll to a certain point in time that spans a whole bunch of different transaction log backup jobs. So we create one disk, and it's as large as is needed for your full retention. So you might even say, I'm only keeping in my snapshot pool database backups for 2 days, but I want to keep logs for 7 days so that I can use them in conjunction with data that I've put into the dedupe pool or that I've put into my OnVault pool, the object storage pool. And so we create that single disk large enough to handle the full retention. What we then do is we actually kick off a traditional SQL Server transaction log backup, and we point it at the Actifio mounted disk. So there's really no magic there other than the fact that it's using a storage protocol for the data movement, and it's SQL Server doing the data movement rather than our Actifio connector. The connector is just initiating the transaction log backup. Now, one thing that we've put into the product that is kind of an important thing to understand, it's one of the things that, hey, just make it work that we did to achieve that. If you're familiar with transaction logs and backups, you also know that you cannot run a transaction log backup on a new database until you've done an actual full backup of it. Yet with Actifio, we never really do a full backup of it in SQL Server terms. We always do a VSS backup. You can see the log entry in SQL Server from our database backup jobs that a backup occurred, but it doesn't do the same style of backup that initiates the log sequence numbers in a way that you can do a transaction log backup. And so when you run a transaction log backup with Actifio on a database that has never had a real traditional full backup done, what we did to make it, quote unquote, just work was we created some code that runs a full backup. It runs it to the built-in device on every Windows server. That's the equivalent of a Linux dev null. It runs it to :null, which means it actually forces SQL Server to read the entire database files and write them to null, meaning throw away all of the data. But because it's gone through the process of reading it, it initiates all of the pointers and all of the flags that are necessary to enable transaction log backups. So just a word of caution there. If you do have a database that has never had a full backup and a real full backup, and you want to run transaction log backups on it, the first time you run the transaction log backups, you might see more read activity than you would have expected, and it might take a little longer than you would have expected for a transaction log backup. And that would be when it's doing this fake full to null in order to initiate those pointers. So after we run the transaction log backup, the next thing that we have to do is manage retention, because I already told you this disk is large enough to handle the full retention. So we're putting data onto it. We also have to take data off of it. So the connector, after it validates that your transaction log backup has been successful, it looks onto those mounted disks and it finds any logs that are beyond the retention period, and it deletes the files. Now, when I say the files, these are the files you're accustomed to seeing with SQL Server. They're .trn files. They're nothing special. We're not doing any bitmap tracking or magic with this. They're just transaction log files. So we run a transaction log backup to our disk. We delete the older logs that are beyond expiration on the disk. Then we unmount the disk from the server, just like we do with databases. And then we take a snapshot of it. Now, this snapshot is for integrity. And what I mean by that is, if you have a job that, say, fails for some reason, well, part of our failure process is to roll back the changes. Well, the way that we do that is by having a snapshot of the last successful job, and we can use that to roll back the full disk to look like the last successful point in time. So that means that on every job, as we repeat over and over and over again, we take one new snapshot at the end of the job and then delete the one from the previous point in time, because we don't want to keep that one. That will have data that's beyond its expiration on it. We're not using snapshots to manage expiration with transaction logs. We are for database backups, but not for transaction logs. Now, this approach has a really nice benefit to it, because when you want to access the data, all we have to do is mount the database disks to the target server. And if you chose to do a point-in-time recovery, we only have to mount one additional disk, and it has the full range of transaction logs on there that are then used to roll the database to the point in time that you've specified. So that's our integration with transaction logs. There's a couple other minor topics I'll cover when we get to some of the best practices there. So SQL Server availability groups. These are getting more and more popular. In fact, it is incredibly rare these days for me to speak to a customer that doesn't mention them. It seems like it used to be about a year and a half ago, everyone was experimenting with them, exploring them, thinking about them, and only the most forward-thinking, leading edge shops were using them in production. Now that has shifted, where I'd say probably 50% of the customers that I speak with have availability groups deployed in production at this point. And the other 50% or 49% are talking about it, experimenting with it, considering it. They're looking at it in some way, shape, or form. It seems like the trend is definitely going towards anything that needs remote site recovery is going towards SQL Server availability groups. Just like with Microsoft Exchange years ago when they introduced DAG. Instead of doing Microsoft Exchange failover clusters, everything went to DAG. And at first, all the storage people were scratching their heads. Why would you do that? You need 2 full copies then. And the answer was storage was cheap and the process was way more reliable, less buggy, less complex than the failover clusters were. I'm seeing that same trend happening with SQL Server and availability groups right now. So what we've done with SQL Server availability groups is, first of all, we've built awareness into the Actifio connector. So when you run a discovery, it sees databases that are in availability groups and they show up in the UI under availability groups. And this is important because in the UI today, everything shows up under this source instance that it's under, except databases and availability groups. Why? Well, because availability groups aren't tied to a single instance, right? They are in multiple instances. One primary and one or more, 0 or more secondary, I guess 1 or more secondaries. And the interesting thing about this is customers are so accustomed to backups being very high impact that Microsoft built into the availability group structure, architecture, the ability to run backups from the secondary instead of the primary to help minimize that impact on production performance and response time. And they built in functionality so that you can not just back up the database from the secondary, but you can even back up and truncate transaction logs from the secondary. And it'll send the truncate command over to the primary, and only the logs that have been processed on the secondary get truncated from both all at once, so that to the backup vendor, it's supposed to be seamless. Just run the backup on the secondary and everything just works. Microsoft put a lot of effort and time into that. The thing that's ironic about it is the technologies that are coming out now, and in particular Actifio, they make it so that there isn't really a big impact on the production anyway. So the very thing that was the driver behind backing up from the secondaries, the big performance impact, we had already addressed. Nonetheless, it is just as common for me to talk to a customer who's looking at or using availability groups as it is for me to see them say, I want to run the backups on the secondary. And so we built this awareness where we discover availability groups separately, and you can choose where you want to run those backups from, the primary or the secondary or any of the particular nodes. Most often, even though it's not necessary, most often people say, I'm going to back up from the secondary. And so in that scenario, it's going to work exactly the same way with the bitmap and with mounting disks and capturing the data into the Actifio appliance. It's just getting it from the secondary instead of the primary. And if the secondary and primary are in different locations, the customer typically uses something like stream snap replication to get that data to the opposite location. So site A might be their primary production site. They're actually running backups at site B off of the availability group secondary and replicating it to site A. This has a benefit, and it has a little bit of a penalty. The benefit is comfort level. People are more comfortable running the backups from the secondary. They feel like it gives them a higher level of isolation against problems with the backup impacting production. The penalty is your recovery point for local. So you're at production, a backup ran, and you want to access the data in that backup to get something out of it, to do some investigation into a problem that's been reported. You either have to wait for the backup to be replicated back to the primary site, since the backup happened at the secondary, or you can do that investigation by mounting to a server at the secondary site, at the site B, right? So you might never be impacted by this if the properly sized environment is deployed, where your backups run and replication finishes and all that before you ever come in the morning. Then it's a non-issue, but you do have that slight lag in your RPO at your primary site because you're not backing up there. It's actually backing up elsewhere and replicating there. Okay, so availability groups provide a really interesting challenge when it comes to doing restores. Now, I'm going to talk a little bit more about restores towards the end of this, but just keep in mind that a restore in the structure that I'm talking about here, this is where your production database is gone or is corrupted, and you truly need to roll it back to a previous point in time. This is the 1% or the 2% scenario, not the 90, 98 or 99%. Most of the time, you're just accessing some data to select something that you need or do some investigation. You're not actually rolling back the true online production database. But when you need to, nothing else is more important in your whole environment than getting that done and getting it done fast and having it work, because you're down while you're waiting. So what we did with our implementation of backups and availability group awareness was we said, okay, if you want to do a restore of an availability group, one of the challenges that you face is getting the data in sync across the two locations. So what we did was we added a feature, and I'm going to go into it in greater detail next week, but we added a feature called Clone that allows you to not just do the restore on the side where you run the backup, but to do a restore where we're actually copying the data back to your production disks and rolling the database to a specific point in time in all the locations, so that a restore is simply pick your point in time. Well, first remove the database that's being restored, right? It's corrupt, it's offline anyway, get rid of it. Then do at the same time restores or clones in both locations to the same point in time using the UI. And by doing the same point in time in the UI, you're also rolling the databases to the same log sequence number. And that's what's required for you then to do the last step, which is to rejoin the databases, or the database or databases, into the availability group in a join-only mode is what it's called. And when you do that, and they're already at the same LSNs, you no longer have to resync all the data over the WAN. What I have seen a lot of customers struggling with is when they're starting to use availability groups and then they have to do a restore, how long do they have to wait to copy the data over the WAN to do that restore? Here, we're giving customers the ability to avoid that completely by doing local restores in each data center from the local copy, one that was the site where it was backed up, the secondary, and one is the site where it was replicated to, the primary. Now, of course, those could be reversed. We're just as happy backing up from the primary and replicating to the secondary, but the concept is still the same. Roll the databases, restore the databases back to your production disks to the same point in time, join them into the availability group, and avoid the need to re-replicate all that data over the WAN. So I mentioned VSS, and not in the transaction log backups, of course, but in the context of database backups. So we absolutely rely on VSS. And a lot of customers, when we first start having conversations with them about them, I'd say probably approaching 50%, maybe 40% of customers have had some prior experience with VSS that left a bad taste in their mouth. So I wanted to just describe a little bit about the VSS components and how they work with each other, and then how we use them. And then as well as talk about some of the safeguards that are in place that Microsoft has put into VSS and how it gives us the flexibility to do what we do without the high risk of impacting the production environment. Sounds like David, there's a question?
Yes, sir. We do have a quick question. Is there a way to specify the logical sequence number when restoring the backup?
So the UI doesn't provide that capability, no. However, we do have the option when you do a restore or a mount, for that matter, to leave the database in the restoring mode and to have the database log files, the disk that contains the transaction log backups, left mounted. Now, in a normal mount where you're bringing the database online again, we're going to mount up the database file disks, mount up the log disk, use the transaction log backups on the log disk to roll the database forwards, bring it online, and we actually take away the log disk because once you bring the database online, there's no more need for it. But if you choose to leave the database in restoring mode, you can have that disk remain. And then if you choose, you can run your transact SQL, your T-SQL commands natively if you want to get to a specific transaction by LSN or by a named transaction if you choose. Right now, the UI, however, does not expose that.
Thank you, Mike.
So VSS is made up of 4 different components. First, there's the VSS service. It's what I call the VSS engine. It's the core component that manages it all. It's the one ring, if you will. Then you have the writer. The writer is the integration between the engine and the data source. So the writer is provided by typically the vendor that provides the data source. So in this case, we're dealing with Microsoft SQL Server. The SQL Server team created a VSS writer that fits in the VSS framework that the VSS service can talk to, so that when it goes to take a snapshot, it can talk to the writer and say, hey, get these databases into a consistent quiesced state, please, and tell me when they're ready. And that back and forth takes place automatically between the two. The next component is called the provider, and the provider is on the other side from the writer, where it's handling the actual snapshot management. So the VSS framework, the VSS service, It's just the engine. A lot of people think that a VSS snap means that Microsoft is taking the snapshot. That's actually not true. It's the provider that's taking the snapshot. And a lot of implementations out there from a lot of vendors, including just flat out VMware with VMware snaps, they provide their own VSS provider. Storage providers provide their own VSS provider so that you can take a VSS snap that's not actually a Microsoft snap in the operating system. It's a storage array snap on the underlying storage array. Right? The provider is what manages that snapshot. And then, of course, the final is the requester. The requester is what's initiating the whole process and asking the VSS engine to create a snap or delete a snap, etc. The way that we use VSS, Actifio is the requester and the requester only. And this is a really important differentiation because so many third parties provide the provider. They created a provider, and a third-party provider most often introduces high latency. People try to integrate things like change block tracking, for example, into the provider, and we have not, right? But by putting it into the provider, what you've done is you've introduced latency into the snapshot. And the snapshot process is the requester says, please take a snap for these databases. The VSS service says, okay, I'm going to ask the writer to quiesce these databases. Tell me when they're done. And it does. And you see in your SQL Server logs, IO frozen for database X, Y, Z, etc. Then VSS engine goes to the provider and says, I'm ready, go ahead and take a snap. There's a Microsoft provider. The Microsoft provider is very, very fast. It also has a lot of safeguards in it that I'll talk about on the next slide, but it's very fast and it's local inside the machine. And as soon as the provider tells the VSS service, okay, the snap is done, the service goes back to the writer and says, okay, you can unquiesce and resume your regular IO activities. And then once that's finished, the VSS service tells the requester, okay, your snapshot is now ready. So that's the sequence of events. Now, if you look at a system that is doing it with all native Microsoft components, Microsoft Writer, Microsoft Provider, and of course the engine is always Microsoft, what you will see specifically for SQL Server is that your IO frozen messages and your IO resumed messages, they all happen within 1 second of each other. They're very quick. They're typically well under a second. Even on systems, and I've seen this, even on systems where you have hundreds or even 1,000 databases I've seen get snapped in 1 second using the complete Microsoft stack. Now, if you instead have a third-party provider, then what happens is the volume shadow service, the VSS service, goes to the writer, says, go ahead and freeze the IO, do your quiesce. SQL Server does it. Then it goes to the provider and it says, take your snapshot. And then it has to sit and wait. And if that provider has to reach out to a storage array or talk to VMware, if the provider is coming from VM tools, there's coordination across different applications running sometimes on different physical hardware across networks. And believe it or not, the more fully functional and feature rich that provider is, the longer it takes before it comes back and says, my snapshot is ready. And during that time, your IO is frozen. And so a lot of customers, the bad taste in their mouth from VSS is, I took a snap and my user's connections got dropped because they timed out. They timed out because IO was frozen for too long by that waiting for the provider. So using the all Microsoft stack, that eliminates that latency. That's one of the things that we wanted to make sure that we did. Now, in addition to the latency at the time of the snapshot, there's a couple of safeguards that are built into the VSS provider from Microsoft. First is space consumption. You know, it's pretty obvious when you have a snapshot and you've snapshotted a disk that is live and having changes, you're consuming some extra storage, right? Because you have to store the blocks that differentiate from each other. So what we've seen, what Microsoft did, is they said, we're going to prioritize the production volumes stability over the snapshot. And so if you start running out of space to handle storing all those changes, VSS provider from Microsoft will automatically delete snapshots. I've seen this happen sometimes on a customer system where they don't have a lot of free space on their disks and they have a big database or a bunch of big databases. The first full backup sometimes while it's running will fail. And when we look at the failure reason, it says the VSS snapshot was deleted. We look at the Windows VSS logs and it says running low on disk space, deleting the snapshot. So it always prioritizes the stability of production over the snapshot. And that's exactly what you would want. You can handle a failed backup job. And I'm going to tell you in just a second on how you can address that kind of a problem. But handling an outage because you ran out of space on a production volume, well, that's much harder, of course. And while most people, I think, probably know that VSS has that space consumption safeguard, they might not know that it also has an I/O safeguard. And I saw this too just a couple of weeks ago at a customer site, again, trying to take the first full backup on a couple of volumes. They had about 50 volumes in scope, and 2 of them had much higher I/O. And it wasn't even all write I/Os, it was a lot of read I/Os. But what happened was VSS provider, it allocates space to the snapshot. And when that space fills up, then it allocates more. And it does it in chunks. And at the point of time when it does the allocation, it actually has to pause I/O very temporarily, but it has an I/O impact on that production volume. So the way the provider works is it's so tightly integrated with the core disk drivers that it knows to prioritize production I/Os first. And so it sits and it waits for a gap in the I/O long enough for it to do its work that won't affect the production I/O. If it can't get one, it will say, hey, I can't allocate more space for the snap, therefore I have nowhere to store these changes, delete the snap. So even though we had plenty of disk available on those drives, we still had the snaps delete in the middle of our job because it couldn't handle the I/O required to allocate space to the snapshot without impacting the production I/O. And Microsoft VSS provider always prioritizes production over the snap. So how do you get around these problems? Right? Easy. They being Microsoft, they also give you the ability to pick what disk should be used to hold the snapshot deltas. And it doesn't have to be the same one as the source disk. So you can either allocate a new disk or pick a disk that has space. You do want it to be similar performance characteristics to the production disk because it's going to be getting copies of data from production. But you can pick a different disk. And by doing that, number one, space management obviously becomes separated. So you can have a disk with lots of free space on it, use that for your snaps and never worry about the space on your source volumes. And number two, that I/O intensive or impactful operation of allocating more snap space, that goes away from the production disk. It's on a different disk. Now you don't have disk contention for it. And so simply going into Windows Explorer and picking to use a different disk alleviates that problem when it comes up. All right, 2 more topics, and they should be relatively short because I think we probably have about 10 minutes or so before we want to be finished and into any additional Q&A. Management best practices. So I've kind of mentioned offhand a couple of times, but I haven't dug into it, that there's the ability to back up single databases or groups of databases or a whole instance. And in fact, in the UI, we actually present things exactly that way. So for those of you familiar with UI, which hopefully is everybody, if I just jump over to one before, sorry, close those. You'll see that under Application Manager and under App, I see SQL instances. Under the SQL instances, I can select one, and I can see all of the databases under that instance. And I have the ability right on the instance to go ahead and apply a template and a profile. And if I do this, just by default, out of the box, every database in the instance will get backed up, all as a single job with this template and using this profile. In fact, any new databases that show up will automatically get backed up with this template and this profile. Any databases that are deleted get ignored on future backups. They still show up on the list over here, but they don't cause any problems. Right? That's the SQL Instance Management capability that we introduced back in 7.1, I believe it was. So that functionality is there. It has become very popular since deploying it. Now, the default behavior is include everything. But for those of you who were customers before this feature was out, you know that you can also simply pick a database, and then on that database, you can apply a template and a profile. Or you can put databases into a group, because if you group them together, it's more efficient use of resources, and specifically virtual disks. And I mentioned the way we carve out disks is, if I've got a D, an E, and an F drive that have my MDFs, NDFs, and LDFs, and I back up a single database, I'm going to carve out 3 disks. But if I back up a group of databases or the entire instance, I'm still going to carve out 3 disks. So it's much more efficient to back them up in groups than to carve out a bunch of disks for each one. So clicking here, for example, I can see this one is in a group, SQL Server group, and that's going to be listed under groups. So I go to groups, I can see my SQL Server group, I can see the databases that are inside of it. And here's where I applied my template and my profile. Now, back on the SQL instance side, I said that the default behavior is to include all of the databases, but that's definitely configurable. So if I come into select the SQL instance itself, you'll see I have a link here called Manage Membership. And in here is where I define the database inclusion rules, if you will. What database or databases should be included when I run a backup at this quote-unquote instance level. And you can see the way it's been defined here is I have the ability to say all databases, and that's what it is by default on a new discovered instance, a new server. I can say all system databases or all user databases. I think those are pretty clear to anyone familiar with SQL what they are. Those same options exist in native SQL maintenance plans. Or I can say selected databases. And if I say selected, I have a further choice to make, exclude or include. And if you think about this, it makes sense, right? If I say selected databases include, and I select some databases, I'm basically doing the same thing as if I just created a group and put those databases into it. There's nothing dynamic about it. I have told the system, include these databases, and that's it. And if I hit the help icon here, you'll see that it'll say that as well. All the databases selected below will be included in the data capture if the policy template is applied to the SQL instance. Databases added to this instance after selecting this option will not be included in the data capture. Of course not. They're not included. They haven't been selected. On the other hand, I can say exclude, and this is the more common option, is to say either to say all or to say selected and exclude and choose databases to exclude. And in this case, I've said exclude report server and report server tempdb, but anything else is included. That means in this example, MSDB model and master. It also means, and this is probably the most important thing, any new databases that show up will be included in the data capture for this instance, right? It is now dynamic rather than static. Now, down in the bottom, I have ineligible members. These are databases that fall into one of 3 categories. They're either A, protected individually, and I can see small DB, which I had selected before, that one was protected individually. They are in a consistency group. 1, 2, and 3 were in that consistency group that I showed you. Or they might be mounted from an existing, from an appliance. They're not really part of the instance from a disk standpoint, from a backup standpoint. They're running off of Actifio disks. And because of that, if we want to back them up, we don't want to back them up in a group with all of the rest of the instance. We want to back them up in their own group, because if they are only backed up as with other databases that are mounted from an appliance, we can use a more efficient capture method. Instead of using the change block tracking and copy the data to a staging disk, well, we'd just be copying it back into the same pool of disks that it's already running off of. It's running off of an Actifio mount. So instead, we just do a quiesce and a snapshot and an unquiesce, and we actually snapshot our underlying disks. So it's a significantly faster process at that point. So 3 levels of protectable applications: database, consistency group, and SQL instance. When you want to decide which one to use, you want to consider things like the VDIS consumption, like I mentioned before. You typically don't apply protection to all of the databases individually. It consumes vdisks, and vdisks are a limited resource on an Actifio appliance. It could end up in driving more Actifio appliances than you want to have, which just complicates administration. Retention and backup schedule. If you have groups of databases that need a different retention, well, that's when you might group them into consistency groups and run those backups with different policies, use different templates, or have different retentions. And then, of course, consistency point. And this one doesn't matter so much anymore, but in the past, a lot of people said, you know what, I have these 6 databases for the same application. I want to make sure they get snapped together. The reality is, when you can, in a single command, recover databases to the same point in time using the logs, it doesn't matter so much if the backups happened at the same point in time or not. And then you add to that the fact that you can't get a consistent point across multiple databases that exists in different servers, and then that just further complicates things. So again, transaction logs to the rescue. You really don't need so much these days to have a consistent point in time for backup from multiple databases, so much as the ability to recover to a consistent point in time.
Mike, I've got a
David?
quick question from the audience here. Does SQL AAG still require using consistency groups as it did in the 7X Actifio release?
It does. So I'm going to be covering that in greater detail next week. But because SQL Server availability groups, as I mentioned before, the databases are not tied to a single instance. The different instances can be in different locations. And if you want to back them up efficiently, you need to know where to back them up from. And that can float from one appliance to another. So if we didn't use consistency groups, we couldn't back them up as part of the instance because we would never know if that was the primary or not, for example, or if we're backing up the same database multiple times on the primary and on the secondary. We really don't want to do that. That's just a waste of resources. So what we're in the process of doing, in fact, I think it's on another window that I'm not showing right now, is the initial spec for it, is we are adding the ability to protect at the availability group level, much like we do the instance level. And you'll have the ability to specify things like which node or nodes and which roles, primary or secondary, and have it adjust dynamically. There's some things about that that are fairly complicated, mostly because the different nodes can exist in different sites, and you typically don't want to run backups over the WAN. So we're talking not just about pointing an appliance to do backups from one node or another based on its role, but actually different appliances running the backup based on the role. And so that makes the project a little bit more complicated than the SQL Instance project was. So that's why we didn't release that all at the same time. But yes, we're working on that, but today we still do leverage consistency groups for availability group backups.
Great, thank you, Mike. I look forward to the deep dive next week.
So best practices for backups for SQL Server. A, use the SQL instance level by default. It's dynamic, right? And that's the whole point about why we added it. New databases can automatically be backed up, and 9 times out of 10, that's what you want. Use consistency groups only if you need to. A, if you're already using them, you don't have to turn them off. They will continue to work just fine. You can continue to use them as you have, especially on existing servers, but maybe on new servers, start using the SQL instance instead. B, funny timing on the question there. If you're using SQL Server always on availability groups, and as I said a few times, next week we'll have more detail on that. Or C, and this is one that's not very oftenly encountered. VSS has a limitation that if you try to quiesce databases that require more than 64 disks to be snapshotted at once, it will refuse. It only has the ability to snap up to 64 volumes, or mount points, drive letters, etc. Obviously not drive letters if it's 64 at once. So if you do have a large environment, we do have some customers that have over 100 volumes, 120, 130 volumes on a production SQL server. You can't back up all of those in one shot. So at that point, you separate them into consistency groups, probably based on the disk layouts, so that you minimize the number of disks that need to be snapped as a part of any single job to be under that 64 threshold. And then finally, protect at the individual database level. Really, this is for those special databases only. You need to separate for security reasons a particular database that's sensitive, and you want to assign it a different organization membership, or you have a radically different SLA, backup schedule, recovery schedule, etc. I honestly don't see this being done very often. It's almost always consistency groups and instances. When people are backing up individual databases, it tends to be for testing purposes more than anything else. And then finally, on the management side, transaction logs. Best practice on transaction logs and backups and frequencies. Most customers run their database backups once a day, and then they run transaction log backups more frequently depending on their required RPO. Most often I see about 2 hours in there, which is the example that we have on the screen. You set RPO to 2 hours, and you set your frequency, or your retention, sorry, to whatever you need it to be based on your company's policies. Just keep in mind that a long retention of logs does consume disk. I've had a couple people say, I want to keep 21 days worth of logs or 30 days worth of logs to get point-in-time recovery all throughout the 30 days. You can do that, but just make sure you're sizing it accordingly based on what your daily log generation size is. We also have an option. I didn't put it on the screen here, but there's an option for you to choose if you want your transaction logs compressed. I think by default, I think it is not enabled, but you might want to consider enabling it, or if it, or I don't actually remember what it was. I think we were gonna make it compressed by default, but we didn't want to change existing behavior for existing customers, so you might need to go manually turn it on. But if you do compress your database logs, it's actually SQL Server doing the compression, not Actifio. And what that means for you is it means that down the road, if you wanted to do a mount and mount up your transaction log backups and manually process them using T-SQL commands for some reason, you still can. You don't need Actifio to decompress those logs. They were compressed by SQL Server, and SQL Server knows how to decompress them when you access them. And then finally is replication. And this one is probably fairly obvious. If you want point-in-time recovery at a remote location, replicate the transaction logs. They get replicated to the same place that the database gets replicated to, and they have the same retention that the database has at that on both sides. I should say they have the same retention. The transaction logs are the same retention on both sides. It is independent of the database retention from a retention in that snapshot pool, and that's because you can do things like a mount. If you've got 2 days retention in snapshot and 2 months in dedupe, you can do a mount of an image from dedupe that's a week old and use the transaction logs to roll forward to a specific point in time. That is absolutely allowed.
So Mike, you mentioned that we could enable compression. Is there a set compression level, or is there a range that we could expect?
It's typically, I want to say that the compression is 2 or 3 to 1. We don't have an option to choose the compression level. We just choose the standard that SQL Server does when you enable compression. We do the exact same thing for Oracle as well, by the way, for those that have some Oracle experience.
Great, thank you.
So final topic here is accessing the data. So to access the data, you have 2 basic concepts, mounts and restores. So the word recover is an interesting one that we try to use a lot because people associate it with restore mentally, and restore is what all of the legacy backup and restore products called it. Obviously, they're backup and restore products, but we prefer the word recover because it is so rare these days that customers need to do an actual restore. In fact, in Actifio terminology, a restore means put the data back where it came from, right on top of the original source. If you want to access it on a different server and you actually want to copy the data to a different server's disks, until recently, that wasn't even available in our product natively through the UI. You had to do a mount and copy it either with a command line option or using Windows Explorer because the flexibility of mounts, the performance of mounts is such that 98% of the time you need to access a backup of your SQL Server data, you don't really need to copy it to the target server. In fact, you don't want to copy it to the target server. The bigger the database, the more true this is, right? Imagine I've got a 10 terabyte SQL Server database, and I need to do some investigation off of a backup. Do I really want to call my storage admin and submit a request to allocate 10 terabytes to the SQL Server that I'm going to do this on, and then wait until it's allocated and ready, and then trigger from my backup team a restore to copy all of that data there and wait all of that time as well, just to run a few queries and then say, okay, you can clean it all up? You know, that's a lot of work for people and a lot of time and process. Instead, the QA person or the support personnel could be given self-service access to spin up that 10 terabyte database on their SQL Server. And we'll simply present the disks that already have it on there on the fly, bring the database online to the point in time they want. They can run their queries, and then they run an unmount, and it takes it out. So 98%, at least my personal experience, 98% or more of recoveries don't involve really copying any of the data. For that 1 or 2%, it's important that you can do it, and you can. We added specifically for availability groups a feature called Clone. I'm going to talk more about that next week, but Clone is the way that we copy data to a target server that's not the original target server, the original source server. And I'll dive into details on that one next week as well. But that's just probably the biggest thing to keep in mind is how often you do what type and why. And so once you get that, the what you want to do is very clear. You do a mount almost all of the time. Whenever you need to access the backups, it automates the things that you want. You don't have to wait for storage. You don't have to wait for data to be copied. And you can even use it for beyond recoveries, but for creating test environments and QA environments. You can have these mounts persistent for some time. They can be there for weeks, sometimes months. Isn't uncommon to see. When you do a restore, well, restore is old school, right? It's the 1%, 2% where it's going to copy all of the data back again. So I know we ran a little bit longer than planned. I really appreciate that we've had some questions coming in. At this point, I'll ask David, are there any others?
There are. I kept a couple in my pocket so people could get some in here. The first one is going to be, when a database is going across multiple LUNs, how are they presented in that disk, or are we presenting multiple disks? This is back to the how we create and present staging disks.
Right. So we mirror the disk layout that existed on the source server. So if the source server had a database that spanned multiple LUNs because it had multiple files, and one file on one LUN, another file on another LUN, etc., we mirror that same structure. When we mount it back, you get to choose the mount locations. If you want, it does not have to match the way it was on the source. For example, if the source environment was using drive letters, you've got your M and N and L hold your MDFs, your NDFs, and your LDFs. But when you do a mount back, you really just want to put it all in one place. You don't want to assign necessarily drive letters to it. So you could choose when you do the mount to put it all under a mount point under the D drive. You can say D:/ Actifio / my database. And what you'll see there is 3 folders show up that are actually mount points or junctions. And in there will be the 3 disks that then have the directory structure from your M, your N, and your L drives, all the way down to the particular files for the selected database or databases. Hope that helps.
Yeah, and the next one is it's a bit of a two-parter. Part 1, very straightforward. Can TDE enabled data also be compressed?
You can. Well, so TDE enabled data, you're really only going to be relevant on the logs there. We're not compressing the database backups as part of that backup job. We do store them on a compressed volume on Sky appliances, the virtual appliance, and they do compress a little bit, but not as much as non-compressed, of course, because the TDE, the encryption, typically encrypted data isn't very compressible. On the logs, I think the same is true, right? You can enable compression, but you're not going to get the same output. But to be honest, I haven't tried that one personally. So I'm going on a little bit of assumption there. But you can answer your own question very easily. If you have a TDE-enabled database, run transaction logs just natively. You can do it using T-SQL. You can say do a log backup with no truncate, so that you're not interfering with any production log backups, and do two of them, one with compression enabled, one with compression not enabled, and then you'll be able to see the difference. I think you can choose to compress them, pretty sure. Don't know if it would be very effective. What's part two?
Kind of the second part to that is there's kind of the classical thinking that you don't ever want to try to dedupe compressed data. Now, things have changed a bit. So can you talk a little bit about why we are able to dedupe SQL compressed data when kind of the classical thinking around this is that you never want to try to deduplicate compressed data?
So compressed versus encrypted are two different things when it comes to this. And the reason I highlight that is we do not dedupe transaction log backups, right? I mentioned that the design of the disk layout for transaction logs is to create one disk big enough to hold the whole retention, which is different than how we do the database backups, where you have a different snapshot for each retained backup. And the reason we do that with database backups is because you can then choose separate retentions in Snap versus in dedupe. You can have 2 days in snapshot and 2 months in dedupe, and we'll simply take the image from Snap and dedupe it when we need to do that. That all happens on the database backups only. Database backups are not compressed as part of the backup operation. Remember, we're just copying the MDF, the NDF, and the LDF files. Now, you may have chosen to compress the files natively in SQL Server. And if you have, we still are not negatively impacted by that, because a typical compressed backup is compressed at the time that it's being backed up as part of a backup stream. And so if you take two full backups 2 days apart from each other and compress them, and then try to dedupe them, you will get no dedupe, because they're totally different, because compression is very much sort of stream of consciousness, if you will. It's very sequential as it goes through the file and compresses. And as soon as you hit something that's different from the first file to the second file, everything after that from the rest of the file is all different. So dedupe, very ineffective in that scenario. With us, we're copying the MDF, NDF, and LDF files. Those files are compressed, but when you make a change in the database, it's only updating a block, and it's storing that block compressed. When we run a backup, we're only copying the block that changed. We're not recompressing the whole database as part of a backup stream. We're just copying the already compressed single block. And therefore, dedupe will still be effective because we're just getting the incremental data in. And if you've done something like cloned your database, the compressed blocks on the source versus on the clone are identical on disk. Again, they haven't been decompressed and recompressed as part of that clone. They're just copied. And therefore, the compressed blocks will still dedupe against each other, right? So database level compression in production and dedupe are absolutely compatible the way we do it, not so much on a traditional full dump style backup approach. And transaction logs, which we do compress, and we ask SQL Server to compress stream of consciousness, as you will, as the job runs, those don't ever go into the dedupe pool, because they're already unique data. By definition, logs are unique data, so they're not going to dedupe anyway. They do compress, but they don't dedupe.
Great. I think you nailed hit the nail on the head on that one. And we don't have any further questions.
Okay. Well, tune in next week. I think it's on Tuesday of next week.
That's
for
correct.
Part two, we're going to be talking about some more advanced concepts here. We're going to be talking about failover clusters and always on availability groups. That's one of the core topics that I want to go through, some of the details about how we operate, what we do, why we do it. We're going to talk about data masking and some of the features that we have around data masking, what that process looks like, why you would want to do it, and then workflows, which is very closely related to data masking, and how you would orchestrate the process to happen automatically and leverage that to enable a test and development environment, for example, where you don't want the developers and QA folks to have access to sensitive data that's in the production database. If you do have additional questions or topics that you would like me to drill into, you can absolutely submit those, and you can submit them either as questions now, or you can email myself or David, and we might have time to add in maybe one more topic into next week's presentation. And with that, I'm just going to say thank you very much. I really appreciate all the questions for sure. Lets me know I have an audience out there. It's always hard speaking on the webinars when it's not like a WebEx that I can hear everybody else and we can interact. So definitely appreciate those questions. Thank you very much.
And thank you, Mike, and thanks everybody for joining us this afternoon. Thank you for joining us for another YouTube Tech Tip video. If you like the content you're seeing on this channel, please remember to like the video, subscribe to the channel, and turn on notifications so you will be alerted to any future content.